So we've been talking the last couple of days compound interest, both growth and decay. We've been looking at income where we had the depreciation rate and we looked at what happened. Like, wasn't it something gross? Like after 3 years, most of the cars had lost 50% of their value, right? So we also the other day were looking at exponential growth, and what we were looking at, whether it was exponential growth versus linear, right? Dollars per bag versus like growth per bag. Okay. So today we're talking about the same type of thing. It's going to help you shortcut all of these problems so you don't have to do the table where you find the repeated values over and over again. It's going to save you a lot of time and effort. Okay. So the two general formulas we're going to look at: A equals P, parentheses 1 plus R, close parentheses, and then this is to the T power. So the T here is up in the exponent. Now, this is just another variation of the A sub n problems that we've been doing, like from last semester. So in the A sub n problems, this guy right here would have been A sub n. The P is the A sub 0, it's our initial amount. Okay. The R in all of these problems is a percentage. It's going to be some sort of rate, 25% per year, or like for the car depreciating, it was losing value at 29% per year, something like that, right? Okay. So AN is our ending amount. A sub 0 is our initial. The R is our interest rate, and it could be a rate of growth or a rate of decay. And then T is our time period. So for example, when we were looking at my savings account and we were looking at like what happened to Mrs. Lowney's savings account when I put some money in and then it was growing. Or the other day when we looked at like the population problem where you had 2 million people and the population was growing by 4% a year, right? That would be the case where the population would be like 2 million people. So that problem we did the other day, that was our initial population. And then 1.04 when it was going up by 4% per year. What did the 1 do for us? You have to add the 100%. So this 1 represents 100%, and then the 04 was the 4% adding on. Okay. And then if it was like, then this would have been to the 10th power, how many years this is happening. Okay. So this 1.04 is what we would call the growth. Just a little bit of like vocabulary that you're going to see on the worksheet. Then 1.04 is the growth factor. Growth rate is 4%. So if you were given a formula and your decimal is your and the whole growth factor, just a little bit right there. See that this formula and this formula are the same with one little baby difference. They both have an initial. They both have a 100%. Just divided by the end of the time period. But that comes into play is a problem like example 1. So I'll go ahead, I'll give you guys just a second to get example 1 written down. So on your papers, go ahead and write example 1. You invest 1,000, 8% quarterly. So this compounded quarterly is the new piece of information that we're going to use. It's where it comes in the formula. How do you have after 7? So what's here is if 5%. How do I write 8%? Good, 0.08. But then if it's compounded quarterly, how much am I getting per, well, first off, how many times quarterly?
4.
It's 4. This means 4 times per year. And so if I'm getting 8% whole year, how much would I get each quarter? I would get 8% over the whole year. I would get 2% per quarter. How did you get the 2 there? Yeah, we would divide 8% by 4, and that would give us 0.02% per quarter. So notice up here in this like N up here, the rate was 8%, 4. So this N is number times compounded per. You were compounding by 12 months in a year. If you were compounding daily, you would divide by 365 because there's 365 days in a year. What happens is some banks will give you interest more often than just once a year. And in fact, most banks do. Like, my bank gives me interest every month, like compounding. And so that means at the end of every single month, my bank figures out how much money I made in interest and it adds that to my month. So it happens more than just once. That's going to affect the time period though too, because I have $1,000. I have 1 plus the 0.02 or 102%. Okay. How many 4 times a year over 7 years? 28. Because 4 times per year over 7 years would be 28. And notice up here, this NT, because you do 4 times 7, exactly. So this little 28 came from 4 times a year for 7 years. So now, instead of having to go in the table and figure out what I made every single quarter, every single time for 7 years, you'd have to go through the table like 28 times, and you'd get really annoyed because that would take forever. Instead of having to do the table, you can just plug and chug this bad boy into your calculator. So go ahead and plug that in. So you're going to do 1,000 times 1.02 to the 28. What do you guys get?
1,741.02.
Nice.
You do the parentheses.
You would do the parentheses first, so the 1.02, and then after the parentheses you would do the exponent and then. Although if you guys have scientific calculators or graphing calculators, you can plug the whole thing in all at once and your calculator will do it for you. Okay. So where did the 0.02 come from? The percent per quarter, right? Because it's 8 under the quarters. Where did the 1 come from? The 100%, good. Where did the 28 come from?
4 times 7.
4 times 7, good. And what was the 1,000?
Invested.
That's how much we started with, our investment. Good. So then, just one more example. That's all we're doing, and it'll go quick. So we've got example 2. I mean, it's a lot of writing, but the math itself will go short. Okay. So you have 800 milligrams of Advil in your system. That's, I mean, I think 1,000 milligrams is 2 extra strength tablets. So 800 isn't that much. Okay. You have 800 milligrams of Advil in your system. If the amount of Advil decreases by about 25% per hour, how much will be in your system after 3 hours? So is this one of the situations where it's growth or is this decay?
Okay.
It's decay because it's decreasing, good. And so then the first thing you do is find out how much your initial amount is. How much do we start with?
800 milligrams.
Good, thank you. So we start with 800 milligrams. Okay.
Not done writing yet.
Okay. And then we're decreasing by 25% per hour, which means we're losing 25%, but we're losing that 25% away from 100%. So if we're losing 25, how much are we keeping?
75.
We're keeping 75. And so what you would do here is you would do 1 minus 0.25, because that's your 100% minus your 25%. We've got 100% minus 25%, so you do 1 minus 0.25. And then how many hours is this happening for?
3.
For 3 hours, good. So you would take 800 times the 75% that you're keeping to the third power. And you can plug that in all in your calculator, all in one shot, and just hit enter. What'd you get for it? 337.5, and this is in milligrams.
Is that the answer?
And that's the answer. Now, these problems should all make sense. So when you get done, if you're doing a problem that's decaying, it's decreasing, you should expect your initial amount to go down, right? And if you're doing a problem that's increasing, like the problem we did before where we had 1,000 and it went up to 1,700, you should expect it to go up. So that'll tell you right away if you're doing something wrong, is if like you're expecting it to decrease but the amount goes up, then you've got a problem in there somewhere, okay? And then just to make sure we talk about growth rate and growth factor one more time. So here, the rate would be a rate of decay. It would be a decay rate. And the rate is always the percentage. So what was the percent that we went down by? 25% or 0.25, good. And then the decay factor, I'm writing decay and factor all as one word. Decay factor good is 0.75. It's the number that ends up in the parentheses. Good. All right, that's it for notes. I'm going to hand out the worksheet and give you guys the rest of class to work on this. I do have an answer key, so if you get stuck and you want me to check your answers, I can do that for you. Or if you're all the way done and you want me to check your answers, that works too.